All right, we're going to today look at section 3.5. We're going to be talking about simplifying complex fractions. And a complex fraction is when we have fractions within fractions. So before we really get into the meat here of the lesson, let's do a little bit of review. So these first two questions say, well, first one says solve the equation for x. There are so many things we could do here. Right? The x is here, so we could subtract the 2/3 to the other side and clean that up, and then we could, maybe do some cross multiplying to get x out of the bottom. That's an option. The other option, and you've been seeing a little bit of this in your homework, is to just try to clear out all the fractions at one time. So if I have a denominator of x and a denominator of 3, I could go in and multiply by both of those. Everything is going to get multiplied by 3x. So let's see, here I have an x on top and an x on bottom, so those cancel. I'm left with 1 times 3. Here my 3's will cancel, and I'll be left with 2x. And then over here, I'm going to get 21x. So with one step, I no longer have any fractions. And so now we can subtract our 2x to the other side, and I'm left with 3 equals 19x. And then divide both sides by 19 to get x equals, well, we'll leave it as 3/19. Not the only way to solve that, but my point here is, if you don't like the fractions, let's get rid of the fractions. And the way we do that is to multiply by that common denominator. Okay? All right. Well, maybe we should have done this second one first. This is asking me to multiply these, kind of like we multiplied everything by 3x. I want to multiply this by x squared. So we're going to distribute that x squared. Maybe we should have done this first, like I said, no big deal. So I have x squared times 1, which is x squared, plus. And if it helps, we can write this as x squared times 3 over x, plus x squared times 2 over x squared, right? So I didn't actually do any of the math. Well, I did x squared times 1. But we could just very literally write out what we're going to do, and then maybe put those over 1. All right, so I've got my x squared out in front, plus, we've talked about simplifying. I've got x squared divided by x, which is x, so I'm left with 3x. And then here my x squared cancel, and I'm left with 2 divided by 1, which is 2. Okay, so again, lots of fractions, multiply by x squared, no fractions. Okay, all right, so just as a quick little, this is going to help us out here in a few minutes, it says, what is the least common denominator, the LCD, for each set of fractions? We've talked about least common denominators this year, or lowest common denominators. So if I have a denominator of 2 and a 2 and a 5, well, I know I need a factor of a 2, and I need a factor of a 5. So the LCD is 2 times 5, which is 10. Here, by the way, that's a 1 over 1. I need a factor of x. I need 2 factors of x. Well, I already have 1, so we just need another one. And then I need a 1. Well, that's x squared. Okay. Here I need an a. I need a b. This denominator says I need an a squared, which is a times a. Well, I already have 1a, so we need another one. This is b squared, which is b times b. I already have one of them. I just need another one. So my LCD is a squared, b squared. Okay. All right, let's take a look at the last one. Now these were a little bit different. There was no addition or subtraction, like in this one. But we've talked about this before. Can you factor x minus 3? No, which means it is itself a factor. Then when I have 3 minus x, well, remember we said those are essentially the same thing. If you factor out a negative, whoops. Gosh, let's just rewrite that. If you factor out a negative, then they will look the same. So I need a factor of x minus 3. This one says I need a negative 1. Well, I don't have that yet, so let's put that on the list. And I need an x minus 3, which I already have. So my common denominator, my LCD, would be negative quantity x minus 3. Okay. All right. Good little review there. All right, so let's get into it. So what is a complex fraction? We've already answered this. A complex fraction is when we have a fraction within a fraction. And you can see two great examples below here, right? Within the fraction, I've got a fraction. Within the fraction, I've got three fractions. Okay. How can we simplify them? There's a lot of choices on how we simplify a complex fraction. What I'm going to do is I'm going to clear the fractions by multiplying the numerator and the denominator by the LCD, least common denominator. All right, so let's look. I'm going to use red here. Let's look at this fraction. Here's my big fraction bar. So I have a 1 on top, and I have a pi halves on the bottom. There's only one fraction within this fraction. It's here. So its denominator is 2. So we're saying let's multiply the top by 2, and let's multiply the bottom by 2. This is not the only way to do it. 1 times 2 is 2. And on the bottom, well, pi divided by 2 times 2 is just pi. So now I have a single fraction. Okay. All right, let's look at this next one. When I look at the three fractions that I have, I've got a denominator of 2, 2, and 5. Well, that sounds familiar. Remember, we already said the common denominator for those would be 10. So I'm going to multiply the top by 10, and I'm going to multiply the bottom by 10. We're going to distribute that 10. So 1/2 times 10 is 5. 3 times 10 is 30. On the bottom, 3/2 times 10, well, 10 divided by 2 is 5, times 3 is 15, minus 10 divided by 5 is 2, right? Fractions mean division. And so I get 35 over 13. Okay, so why I like that is because in one step, we eliminate all of the fractions. Okay, all right. Let's take a look at this next one. Lots of fractions in here. Let's look at our denominators. We've got a denominator of x, a denominator of x squared, another denominator of x. Well, we did that above, didn't we? We had a fraction with an x and an x squared, and their common denominator was also x squared. So we're going to multiply everything by x squared on top and everything on the bottom by x squared. Why does this work, by the way? Because what is x squared divided by x squared? It's really 1. So I'm really just multiplying by 1. That doesn't change a thing, does it? Hey, if you look at your warm-up question, didn't we already do this? Didn't we already multiply this quantity by x squared? Whoop, it's already done. We already have the answer there, don't we? X squared plus 3x plus 2. Great, I'm going to go to the bottom, and when I distribute the x squared, I'm just going to say from slide number 1. That way you remember. When I distribute my x squared here, x squared times 1 is x squared, and x squared times 2 over x, well, one of the x's cancels top and bottom, and I'm left with 2x. Okay. Great, so we've gotten rid of the fraction within the fraction. Can we keep simplifying? Well, now this is review. Let's try to factor. So I'm going to try to simplify. So let's see. Does the top factor x plus 2, x plus 1? In the bottom, I can take out an x. Ooh, I love that. Look at that. X plus 2 on top and bottom. And look at how nice that simplifies. So we went from here all the way to here. Great. Pause if you need to. I'm going to flip it over. Whew. Negative exponents. All right, here we go. Remember, a negative exponent means reciprocal. So I want b to the first, but I want it in the bottom. Minus, I want a to the first, but I want it in the bottom. On the bottom, I want a squared, but I want it on the bottom. And then same thing with that second piece. So when we see negative exponents in a fraction, that really means complex fractions. So I have a denominator of b and an a squared and a b squared. We already said earlier today that the common denominator will be a squared b squared. So let's multiply the top and the bottom. Here we go. I have a 1 times all of that, but then I want to divide by b. So that's going to get rid of one of those. Here, 1 times all of that, but then I want to divide by a, so that gets rid of one of those a's. On the bottom, the a squareds cancel, and I'm left with b squared. And here the b squares cancel, and I'm left with a squared. And now we'll try to simplify this answer. But what I love about it is that we've gone from negative exponents to something much nicer. In the top, I think I can factor out an a and a b, and that leaves me with a minus b. In the bottom, that's a difference of squares. That factors into b plus a and b minus a. Woo, I love it. Look at that. A minus b divided by b minus a. Remember, that simplifies to a negative 1. So my final answer is negative ab all over b plus a. That's multiplication on the top there. All right, let's take a look at the last one. All right, here's my big old fraction bar. So in the numerator, I've got a fraction. In the denominator, I've got a fraction. We have already said that the common denominator here between these two is a negative x minus 3. We could do this differently, I'm sure, but that's okay. I'm multiplying by that, not subtracting it. Okay. So if I distribute this, I get a negative 2 times x minus 3 plus, and when I multiply these give me a negative 1, which will cancel with that negative, leaves me with a 2 on top. I'm realizing now that we didn't pick the best denominator. That's okay. We can talk about it in a minute, but let's finish what we're doing here. Here, the x minus 3's cancel, and I'm left with a negative 4. And here, a negative times a negative is a positive, and I'm left with x times x minus 3. Shoot. It's a minus. All right, so let's clean this up. I'm left with a negative 2x plus 6 plus 2 all over negative 4 plus x squared minus 3x. How about negative 2x plus 4 on top, plus 8 on top. And on the bottom I have x squared minus 3x minus 4. So in the top I factored out a negative 2. I'm trying to simplify. On the bottom, let's try to factor that into x minus 4 and x plus 1. Oh my gosh, I just crossed off the wrong one. Ooh, you can tell it's a Friday afternoon, huh? My fault. So on the top I have a negative 2, and on the bottom I have an x plus 1. So honestly, looking at this now, I jumped the gun a little bit. I think instead of using that negative here, I would have just changed this denominator from the beginning. I'm going to come down here. I'm going to rewrite the problem. Obviously, what we did worked just fine. Here's another option. Instead of multiplying everything by negative x minus 3, what if I just came in here and then rewrote that as x minus 3 and just moved the negative to the top? Because now the denominator is already the same. Right, we've talked about that before. So then all we would need to do, now the denominators match, so now all we would need to do is go in and multiply by x minus 3. Okay, obviously there's a lot of choices here, and even still some of you will look at that and say, I would have done it differently, and that is completely up to you.